Hello everyone and welcome to the new chapter of Trigonometry series, the graph of trigonometric functions. So this is actually a new chapter that doesn't involve problem solving actually. Those like finding the side of a triangle, the angle in a given vertex of a triangle. So I think it's a good way to take a break from those by learning this new topic which is the graph of trigonometric function. So remember that there are six trigonometric functions, right? We have the sine, cosine, and tangent, the three most basic trigonometric functions. And then we have the reciprocal functions, which are cosecant, secant, and cotangent. So in total, there are six, and we will learn how to graph them. But what do you call this one? We're going to do it like step by step. I mean, yeah, obviously it is a step-by-step process, but what I mean is that in terms of functions, we're going to focus first on the basic ones, like what are the functions that we need to learn how to graph, like the first ones before we proceed to the other trigonometric functions. All right? Because uh there are trigonometric functions that are different in terms of their properties and steps on how to graph them. All right? So, in this video, we're going to talk about the graph of sine and cosine function. All right, these two, the most basic trigonometric functions that we need to learn when it comes to graphing them. All right, sine and cosine. So here's what we're going to do. Let's just say we want to graph them. All right, but we will graph them by the use of this table here, the one that you just see, the x column and f of x column. The x, these are the x values. They are in degrees, all right? These are angles, but in degrees. To be particular, these are quadrantal angles, 0 degrees, 90 degrees, so on and so forth. You can convert them into radians, all right? Like from 0 degrees, it will become 0 radians. 90 degrees, it will become pi all over 2 radians. So here's what we're going to do. We're going to find the f of x or the y value of each of the given x values. Then we will use that in drawing the graph, all right? So that we know at least the idea on how they look like, all right? So let's start first with sine. All right. So let's just say the f of x or the function that you're going to use is sine, right? So let's begin. If you're going to substitute 0 degrees in the sine function, you will have exactly 0. If you're going to substitute 90 degrees or in radians, pi all over 2 to sine function, you will get exactly 1. If you're going to substitute 180 degrees to sine, you will get 0. If you're going to substitute 270 degrees to sine, well, you will have negative 1. Then 360, 0. All right? So far, from 0 degrees to 360 degrees, this is, by the way, one full complete rotation or revolution, right? Because one whole revolution or rotation, it it is in 360 degrees, right? So from 0 degrees to 360 degrees, we have the given y values or f of x, right? And I think you would notice the pattern, 0, 1, 0, -1, 0, right? So how about we continue? Let's go further 360 degrees. If you would substitute 450 to sine, the answer here you'll get 1. 540, you will get 0. 630, you will get -1. And 730, oh wait, no, this is 720. Forgive me, this is 720. All right, 720. All right, so 720, you will get 0. All right. It seems like the pattern is the same. 0, 1, 0, -1, 0. And from here, 0, 1, 0, -1, 0. So the patterns are in fact the same, you know. But we're not talking about the pattern here. We're going to talk about the graph itself. All right. So now that we have the x values and then the what do you call this one? The outputs or the y values, let's try to graph them. All right. So we will graph them this way. Hold on, let me just draw a straight line. Then this way. All right, maybe this will do. Okay. So let me just input the x values, but I'm going to do it in radians. All right. So what I call this one? 0 degrees, that is zero, so it's in the origin. 90 degrees, that's basically pi all over 2 radians. 180 degrees, that's basically pi. 270, that's 3 pi all over 2 radians. 360 degrees, that's 2 pi. 450, I do believe that would be what's 450? Hold on. 450. Wait. 2 pi plus 5 all over 2. Right? 5 all over 2 pi radians. So here we have uh yeah, wait. 2 pi 360. 450 is 5 pi all over 2. 540, I do believe that would be 3 pi, right? 3 pi. Okay, that's for 540. I think we're going to stop right here. No, let's continue. All right, let's continue. All right. So yeah, where were we? Yeah, 360, 450, 540, 630. So 630, I think that would be 7 pi all over 2. And for 720, that would be 4 pi. All right. So here our y values are from -1 to +1. So let's just say this is +1, 0 is at the origin, and -1 is here. So let's plot them, all right? Okay, so let's start first with the beginning. 0 degrees or 0 radians. So according here, you will get a y value of 0. So that means it's at the origin. It's here. Oh wait, no, it's here. Next, 90 degrees or pi all over 2, you will get 1. So here, you'll get 1. 180 degrees, 0, which is the same as pi radians for 180 degrees. So we will have this. 270 degrees, 270 degrees is just the same as 3 pi all over 2. So this is -1. The next 360 or 2 pi, that's basically 0. Then next we have 450 degrees, which is 5 pi all over 2. You will get exactly 1. Then 540 degrees, which is 3 pi. Oh, wait, yeah, which is 3 pi. That would be 0. Let me just put it here. Then what's next after 3 pi? Yeah, 630, which is -1, which is 7 pi all over 2. I mean, 630 degrees is just the same as 7 pi all over 2. So here. And lastly, we have 720 degrees or 4 pi. That is 0. Now we're going to trace the curves. Now look at this. All right, that's it. All right, that's it. See? Oh, no, no. There you go. So this is the graph of sine. It's actually a wave-like graph. Oh, wait. Let me put down my camera. That's it. Right? There we go. So this is actually a estimate graph of what sine look like, you know. So yeah, that is what sine look like, but how about cosine? Let's do cosine. So for cosine, here's what we're going to do. So the same x values, 0 degrees up to 720 degrees, all quadrantal angles. All right. Then after that, we're going to what's that again? We're going to graph them. All right. So just the same thing on what we did to sine. All right. So first, let's try to substitute all the quadrantal angles to cosine. So let's try to begin substituting 0 degrees to cosine. If I would substitute 0 degrees to cosine, that would be 1. 90 degrees, 0. 180 degrees, -1. 270, 0. 360, 1. So here, from 0 to 360 degrees in one whole rotation or revolution, you have like these values. All right, 1, 0, -1, 0, 1. Okay? So next we proceed. So 450 degrees, 0. 540 degrees, you will get negative 1. 630 degrees, 0. Then lastly, 720 degrees, 1. All right? So the pattern is just similar as the signs, you know. But again, it's not about the pattern here. What we're going to do is we're going to graph them. All right? So let me just draw another graph of this. Let me just copy this one. All right, let me just put it here. Okay, that's it. Let me just put my camera up. There we go. Okay, so let's erase the points as much as possible. Okay. All right. So, oh wait, no. There you go. So let's start first with 0 degrees or 0 radians. So according here, um, 0 radians, you will get 1 as your y value. So it's here. All right. 2, 90 degrees or pi all over 2, you will get 0. So it's on the axis. Next, 180, which is pi radians, you will get negative 1. So it's here. 270, 3 pi all over 2, 0. 360 or 2 pi is exactly 1. 450 or 3 pi all over 2, you will get 0. 540 or 3 pi, you will get negative 1. 7 pi all over 2 or 630 degrees, you will get 0. And lastly, 720 or 4 pi, 720 degrees or 4 pi will give you exactly 1. Then we will graph them. We will trace the points, I mean. So let's take a look. Right? So it's a W shape, if you're going to take a look. Wait. All right. That's it. So yeah, this is the graph of cosine. All right. You see the difference here? So the red ones, you see, it seems like it starts from the 1, then it goes down and up, down, up, down. So if we're talking about the pattern, I think you would notice the movements of the curve, from top, down, top again, but the same height as the before. Then you'll go down, up, From here, for sine, seems like you're going to start at the middle, like at the origin. Then you go up midway, then you go fully down, then up again, then down, and so on and so forth. Right? So yes, this is by estimate, this is what sine and cosine look like. Another cool thing about knowing the graph of sine and cosine is its relation to unit circle. Do you remember the unit circle? Remember that in the unit circle, this is like the circle itself centered at the origin, and the length of the radius is always at 1 unit. Now, let's take a look closely here. We have like the coordinates of this point, of this point here at the corner here. So we have a given coordinates 0.866 and 0.5. Now, here's the thing. You see those green colored lines, all right? Think of it that you form a right triangle, all right? So the vertical part, that's the green part. The horizontal part, that's the orange part, all right? So here's the thing. In the unit circle, the orange part or the horizontal part of the right triangle is x, while the green part or the vertical part is y. But also remember that the x or the horizontal part is cosine. Remember that. And the vertical part is sine. All right? Remember, your x is cosine, which is the orange, and your y is sine, which is the vertical. So take a look at the coordinates. We have 0.866. That's your x. So that means that at that moment, your cosine is 0.866. And here your y is 0.5. That means your sine is 0.5. Now let's take a look. Let's do some experiment like, what if we rotate the angle starting from 0 degrees or exactly at the x-axis? If you're going to observe here at 0 degrees, Your x is 1, your 0 is y. So what does it mean? Meaning that your cosine is exactly, cosine 0 degrees is 1. Sine 0 degrees is 0. Now, here's what's more interesting. What if uh, we rotate it upward like this? Take a look. At exactly 30 degrees, you have coordinates of 0.866 and zero point 0.5, just like earlier. So meaning cosine 30 is approximately 0.866, while sine 30 degrees is zero point 0.5. Now, what happens if we go further as it approaches to 90 degrees? So meaning, as it approaches to 90 degrees, if you're going to take a look, the x value decreases. The base of the right triangle decreases, while the vertical, the green part, increases, as if it almost approaches to 1, which at 90 degrees, it did. All right. So here at 90 degrees, your cosine is 0. Cosine 90 degrees is 0. Then sine of 90 degrees is 1. All right. So I think you get the visuals here. All right. But here's the thing though. All right. How is it even related to the graph of a sine or cosine? All right. So let's focus here on the on the y value, all right? The one that is on the zero point 0.5, all right? Let's focus on that, okay? So here you start from 0, 0.1736, 0.342, 0.5. Let's focus on the y value, all right? So in a certain revolution, all right, we have a given y values, all right? Like right now, you see it. Right now, it has 0.829. Here we have 1. We have 0.766, so on and so forth. So we're going to focus on the y value. All right. Focus on the y value. All right. So here's the thing. All right. I'm going to focus first on the sign. All right. So here's what will happen. All right. Uh, Look at here at the orange part, all right? The orange part here, the radius of the circle, all right? The the orange or orange, sorry. What's that again? The color pink of the curve, right now you see this color pink, that's the sine graph, right? So let's focus on the sine and the radius of the circle, all right? So let me just erase this one, all right? Here's the thing. Right? We start first at the very at the x-axis itself, where your y value is 0. But here's what will happen. Look what will happen. All right? Let me zoom out. Okay, there we go. What did you observe? So let's do it slowly. Okay, let's do it slowly. Okay? Look at the y value. Okay? 0. Then, as it increases, reaches 0.56, look at the graph of the sign, which is the color pink. All right? So it goes up and up until it reaches at the peak where your y value is exactly 1. Then we go further, you see your y value decreases, in which at this point it became 0.516. All right? And then we go like exactly at 180 degrees, right? We're here at 180 degrees, okay, or pi radians, you will get exactly 0. So, so it makes sense why it's on the x-axis. Then we go further, right? And further and further and further and further. All right. So this is what sine function look like. All right. So that is basically how it looked like for sine. Now, how about for cosine? Now, for cosine, okay, let me just go back again at the very beginning. Okay, let me just not include the graph of the sine. Okay, so here for cosine. Now, take a look at the cosine. So remember that in the graph, right, it always starts at the 1 exactly, right? So here, take a look. Okay. So since at that moment where your radius is at 0, your coordinates are 1 and 0. So that means cosine 0 degrees is exactly 1, which is here on the top. All right. You see this on the top. Now we go further. All right. What if we rotate the what's that again? What if we rotate the radius? So here's what will happen. Okay. There you go. All right. Let's zoom out. Right, there you go. Okay. So that means that, you know, if we're going to take a look or analyze it very carefully, okay, from 0 degrees going to 90 degrees, your graph of cosine function would look like this. Then going to 180 degrees, it will look like this. Then going to 270, it will look like that. Then going to 360 degrees, it will look like this. All right. Then in here, the pattern repeats. All right. It will go further like that. All right. So that is the graph of cosine. All right. Now, here's the thing. The very interesting part here is what if we combine them both? All right. I think it's much better if you're going to combine them. All right. So take a look at this point. Look at that. The green is cosine and the pink is sine. Look at that graph. All right. Take a look. See? So that is how sine and cosine form. All right. So here, at least you get the idea on how they look like. So the next video, we're going to graph them both. But let's focus on them one by one. All right. Let's focus on sine and cosine one by one. And that is all, guys. So see you soon.